Alright, in this video, we're going to learn how to solve trigonometry equations. The problem sums we're going to manage are those equations that involve only one trigonometric functions. So therefore, there's no need to use the identities, don't need to use addition formula or double angle formula. Right, let's look at the first questions. So you asked to solve the equations 2 sine square x equals to 1, and the range given to you will be between 0 degrees, inclusive of 0 and 360 degrees. Right. Alright, so I have written down all the steps and the solutions that we need to do. So let's look at the steps. So step number 1, we need to make sine x the subject. Right, because we're solving trigo equations, so we need to make the trigo functions the subject on the left-hand side. Right, then the second step is to find alpha. If you recall, alpha is the reference angle or the basic angle. And because alpha is an acute angle, so hence we need to trigo inverse the positive value. Right, so if you look at the solutions, right, we need to make sine x a subject. So from 2 sine square x equals to 1, you get sine square x equals to half. All right, so this is similar to when you solved algebraic equation. If you have x squared equals to 4, then what are the possible values of x? It will be positive or negative too, right? So likewise, if you have sine squared x equals to half, then the possible values for sine x will be positive, negative, square root half. And this one here, if you were to apply the rules of the third rule, where if you have square root a over b, you can actually simplify it into square root a over square root b. Right, so in this case here, you can simplify it into square root 1 over square root 2. And of course, square root 1 is 1, so you get 1 over square root 2. All right, so that is the first step. Right, then second step is that we need to find alpha. All right, so bear in mind again that alpha is an acute angle, so we need to sine inverse a positive value. So even though if you can see that we have plus and minus 1 over square root 2, we only sine inverse the positive value, which is 1 over square root 2. So sine inverse bracket 1 over square root 2 gives you 45 degrees. You can use a calculator to evaluate that. Right, so the third step is to determine where the angles can be found. And this is where you have to use the ASTC to guide you. We're talking about angles taken in a anti-clockwise direction. So for sine to be positive, right, it will be in the first or second quadrant. And then for sine x to be negative, it will come from the third and the fourth. So in other words, if you have sine x equals to positive, negative 1 over square root 2, the angles will come from all the 4 quadrants. All right, so the first quadrant here, as I've shown you, x will be equals to alpha itself, which is 45 degrees. Then for the second quadrant, it will be 180 minus alpha. So 180 minus 45 gives you 135. Third quadrant will be 180 plus alpha, which is 180 plus 45, give you 225. Then the last quadrant, the fourth quadrant, sorry, not the last quadrant, is the fourth quadrant, will be 360 minus alpha, which is 360 minus 45, give you 315 degrees. All right, let's look at the second question. This is a relatively easy question. Only thing is that the range that must be, the answers for the x has to be in radian mode. Okay, there are two kinds of units to measure angle. It can be in degree, what we have done earlier on, or it can be in radian. So in this question here, you have to leave your answer in radian. Right, but the steps are still the same. Step number 1, you have to make sine x the subject. All right, so as what I've demonstrated here on the solution, right, we group all the sine x together. So 2 sine x minus 3 sine x will give us negative sine x. Negative 2 plus 1 gives you negative 1. Then you divide both sides by negative 1. If you divide both sides by negative 1, you end up with sine x equals to 1. So that's step number 1. Right, step number 2 is to find alpha. Right, so let me remind again, the alpha is in the cube angle. So we need to sine inverse a positive value. So sine inverse 1. So sine inverse 1 is 90 degrees. And because the questions require you to express your answer in terms of radian, so 90 degrees is pi over 2. Right, so why is it pi over 2? Just do a recall that the conversion is 180 degrees. It's equals to pi. It's just that when you do conversions of cm to meter or meter to cm, like 1 meter is 100 cm. So it's the same. Because angle can be measured in degree or radian. So that's why we need to know the conversions. So 180 degrees is equals to pi radian. So therefore, 180 divided by 2 will give you 90 degrees, which is pi over 2. So 90 degrees is pi over 2. All right, then step number 3, it's our ASTC again. All right, we're talking about angle between 0 to 2 pi, so it's angle measured in a anti-clockwise direction. So the positive value will be, since we're talking about a positive answer for sine x, it will come from your first and the second quadrant. So the first quadrant will just be alpha itself, which is pi over 2. Second quadrant is pi minus alpha. So it's pi minus pi over 2 also gives you pi over 2. All right, now let's look at another question. This one is slightly harder because we need to do some factorization. Right, if you were to examine the trigo equations given, all right, this is actually a quadratic equation. All right, so if you were to let cosine x equals to a, then you will see that you actually get 2a squared. All right, cosine squared x, okay, cosine squared x, it's actually just cosine x multiplied with another cosine x. So if you let cosine x be a, then it's just a times a. That gives you a squared. So you will have 2a squared plus a minus 1 equals to 0. And this is actually a quadratic equation. And you can factorize it using this method, the cross method. So here I would have 2 cosine square x, negative 1, then cosine x here. Right, so we have 2 cosine x multiplied by cosine x. And then you have a negative 1, 1, 2 across. So that will give you negative cosine x and then 2 cosine x. Right, so this will be one factor. And this is a second factor. Right, so that's what I have there on the screen there. So you can apply the zero product rule. That will give you cosine x equals to half or cosine x equals to negative half. Oh, sorry, negative 1. Right, so we have to solve for 2 equations. Right, step 2 is to find your reference angle. Okay, so I've separated it into 2 columns here. Okay, let's look at this one first. Cosine x equals to half. Right, so your alpha will be just cosine inverse half, and that's 60 degrees. And because you need to leave your answer in the radian, in radian form, you need to convert your 60 degrees to radian, which is pi over 3. Pi is 180, so 180 divided by 3 gives you 60 degrees, so pi over 3. All right, so cosine x equals to half. Half is a positive value, right? Positive value. So look, your ASTC, it will be first and fourth quadrant. So first will be just alpha itself, which is pi over 3. Then the fourth quadrant will be 2 pi minus alpha, which is 2 pi minus pi over 3, gives you 5 pi over 3. So that settles cosine x equals to half. Right, so how about cosine x equals to negative 1? Right, so we need to cosine inverse 1. Okay, always remember alpha is a cube angle. That's why when we trigo inverse, it always trigo inverse a positive value. So cosine inverse 1 gives you 0 radian. All right, so for cosine x to be a negative value, your ASTC again, you come from second and third. Right, so second quadrant is 180 minus alpha, so it's just pi minus alpha gives you pi. And then because your alpha is 0 radian, then third quadrant is pi plus alpha, so pi plus 0 gives you pi. So you have the same answer for the angle in the second and also in the third quadrant. All right, let's do a more challenging questions. All right, in this case here, yeah, it's more challenging because you are actually dealing with 2x minus 40 degrees. The first few examples we have done are just sine x or cos x. Okay, we're talking about just sine 1x or cos 2x. Now we're talking about cos bracket 2x minus 40. So in this case here, the step number 1, we have to find the new range. Okay, so your final answer must be between 0 degrees to 360 degrees. That is your final answer here. You asked to find the value of x. So what you're finding finally is the value for x, which should be between 0 degrees and 360 degrees. Okay, however, before we can reach that, right, we need to settle this guy, because you're not given cos x, you're given cos bracket 2x minus 40 degrees. So before you can reach your x, right, you have to find the possible angles for 2x minus 40 first. So therefore, we need to find the new range. Okay, so the new range, that means the range that what should you call it the in-between. The in-between range should be between negative 40 to 680. Right. And then second step is to make cosine bracket 2x minus 40 degrees the subject as usual. And then third step is to find alpha. And then the last step is to determine the quadrants by using ASTC. All right, so let's look at the solutions and see how we can go about solving this question. All right, so we're going to make cosine bracket 2x minus 40 the subject. So that gives you negative 1 bring over become 1. So 1 divided by 3 gives you 1/3. Second step, find alpha. So cosine inverse 1/3 is 70.53 degrees. All right. Okay, so the third step is we're talking about a positive ratio. Okay, and then so if you draw your ASTC, right, it will come from, yes, we're talking about angle. All right, because there are two different kinds of angles, angle measured in the anti-clockwise, also angle measured in the clockwise. So angle measured in the anti-clockwise direction, for a positive ratio, it's from the first quadrant and the fourth quadrant. All right, so first quadrant, first quadrant is just alpha itself, so which is 70.53. The fourth quadrant will be 360 minus alpha, so 360 minus 70.53. All right, so this is a tricky part. The tricky part is that you see the range that you're given, it's all the way to 680. So which means we're talking about 2 cycles. Yeah, we're talking about 2 cycles here. So the first cycle is 70.53. This is your first cycle. All right, so we need to add one more cycle to it. One cycle is 360 because if you talk about unit circle, right, you go around one circle, start from here 0, here 90, 180, 270, 360. Right, so one round is 360. So if you're talking about 2 rounds here, whatever answer you get for your first answer, which is 70.53, you will have to add one more round. Likewise, for the answer in the fourth quadrant, you add one more round. Okay, and then finally, you whatever answer you have here, 70.53, you must plus 40 divided by 2 to give you this guy here. Okay, so this answer here, plus 40 divided by 2 to give you this. This one here, plus 40 divided by 2 to give you this. And finally, the last one, plus 40 divided by 2. All right, so we also have this angle that is measured in a clockwise direction. All right, but we don't have to worry that. Why don't you have to worry that? Because if you were to draw your ASTC, all right, angle in a clockwise direction, for cosine to be positive will be first. Okay, and if you measure angle in a clockwise direction, then this guy will become the first quadrant. The way you name your quadrant will be different really. Okay, if you measure angle in the clockwise direction, then the quadrants, the way you label the quadrants will be different. That will be your first, second, third, fourth. So for positive to be cosine, for cosine to be positive, it will come from the first and the fourth. So the first quadrant means your 2x minus 40 degree, right, will be equals to negative alpha, right, which is negative 70.53. So your negative 70.53, it's outside this range already. It's outside your negative 40 degrees. So therefore, you don't really have to bother about this because it's not within the range. Okay? Right, let's look at the even more challenging questions. Why is it more challenging? Because in this case here, we have to deal with angles as measured in the anti-clockwise direction and also deal with angles that's measured in a clockwise direction. And not only that, okay, we are not solving for tangent x only, we're solving for tangent bracket x minus 3. So that makes the question even more challenging. All right, so but if you do it in the systematic way, right, if you understand the concepts, and if you remember the steps and do it in a systematic way, it's not difficult. So step number 1, right, we have to find the new range. So your final answer is, okay, your final answer must be between x. The final answer must be the value of x, which is negative pi to 2 pi. However, before we can reach that, okay, we have to find the range for x minus 3. All right, so to simplify things, right, we will just convert 2 pi minus 3. You can use a calculator to work out 2 times pi minus 3. That will give you 3.283. And then negative 5 minus 3 will be negative 6.142. So in other words, you have to settle with anything that's between 0 to 3.283, which is the angle measured in the anti-clockwise direction. You also need to settle anything that's between 0 to negative 6.142, which is angle measured in a clockwise direction. All right, step 2, find alpha. Then step 3, of course, is to determine the quadrants where x can be found by using the ASTC. All right, so let's look at the solutions. Right, let's make tangent bracket x minus 3 the subject. All right, so take the positive one to the other side, become negative 1, divide both sides by 3. So you get negative 1/3. All right, so that's step 1. Step 2, find alpha. Okay, tangent inverse 1/3 is always tangent inverse a positive value. Okay, always remember alpha is an acute angle. So always trigo inverse a positive value. I keep mentioning that you have 0.3218. Okay, so here it's going to be a bit tricky. I'm going to divide this into, I'm going to split, okay, the range that you need to find. This guy here, the answer, I'm going to split it into positive and negative, right? So into angle in the clockwise and angle in the anti-clockwise direction. Okay, so this is angle in a anti-clockwise direction between 0 to 3.283. All right, so tangent, if you have a negative ratio for tangent, then under your ASTC, angle measured in a anti-clockwise direction, it will come from second and the fourth quadrant. All right, so x minus 3 will be equals to, second quadrant is pi minus alpha. So which is pi minus 0.3218. That is second quadrant. And then the fourth quadrant, okay, so what happened is that the fourth quadrant is 2 pi minus alpha. But if you use a calculator to work out 2 pi minus alpha, it will be out of this 3.283. Because the range must be between 0 to 3.283. All right, so you can just use a calculator. Take 2 times pi minus 0.3218. You will realize it's out of this range. So you don't have to consider the fourth quadrant. You just need to consider the second quadrant. So pi minus 0.3218 then plus 3 will give you the value for x. Okay, so this is easy. You're dealing with angles in the anti-clockwise direction, so it's easy. So how about angle in the clockwise direction? So that will be between negative 6.142 and 0. So in this case here, the diagram that you draw will be different already. Okay, the diagram we draw will be different. All right, so okay, So this one, if your angle is measured in a clockwise direction, then this guy become your first quadrant. Okay, show you the difference. This is your first. This is your second. This is your third. And this is your fourth. But if you're talking about angle that's measured in the clockwise, this is your first. This is your second. Third. All right, so can you see the difference? All right, but for tangent to be negative, right, it's whether if it's measured in anti-clockwise or clockwise direction, all right, it still come from S and C. Can you see the quadrants for tangent to be negative is the same? All right, it's just that in this case here, okay, we're talking about second and fourth quadrant. But here, okay, because the way you name the quadrant is different really, it's no longer second and fourth, it has become third and first. All right. So what is the answer for the first quadrant? Will be x minus 3 equals to negative alpha. Okay, will be just negative 0.3218. And then for the third quadrant, it will be negative bracket 180 plus alpha. All right, so 180 is pi, so it's negative bracket pi plus alpha. That gives you negative 3.463. Then finally, you find for x. So the first answer will be negative 0.3218 plus 3. That gives you 2.68. Then the second answer will be negative 3.463 plus 3. Give you this negative 0.463. Okay, so this is a bit confusing. It is definitely not easy. So maybe you have to, not maybe, I will encourage you to look through a few times in order to really, really understand the concepts. All right, so we have done some very difficult questions. Now let's solve some questions that it's easier. So I won't be writing down all the steps. After dealing with so many questions, 4 questions altogether, more than 4 questions because some questions have part A and part B, you would have already internalized the steps. Okay, you've already understand the concepts behind and then internalize the steps. So let's look at part A. Right, so there's no need to find new range because you're finding for cos 1x. And finally, your answer x must be between 0 degrees to 360. So you just straight away go and find alpha, which is cosine inverse 0.5, 60 degrees. And then draw your ASTC. So for cosine to be positive because you are dealing with cosine x equals to 0.5. 0.5 is a positive value. Okay, so for cosine to be positive, then it will come from the first and the fourth quadrant, A and C. A means all the trigo ratio will be positive. C means only cosine ratio will be positive in that quadrant. All right, so first quadrant will just be alpha, 60 degrees. Fourth quadrant will be 360 minus alpha, which is 360 minus 60, 300 degrees. Okay, relatively easy. Let's look at part B. So for part B, some of you will be like, what to do with tangent 20? Don't worry, anything that you can actually use a calculator to help you, just use calculator to evaluate. So when you use calculator to evaluate tangent 20, you get 0.36397. All right, so the next step is to find alpha, and then your ASTC. So because we are talking about positive value for sine x, so the angle will come from the second and the first quadrant. So the first quadrant will just be alpha, which is 21.3, and then the second quadrant will be 180 minus alpha, which is 180 minus 21.34 gives you 158.7. All right, so for part C, we will have to find a new range. Why need to find a new range? Because you're asked to find cosine 2x. So your final answer is x between 0 to 360. But before you can even reach that, you have to find 2x first. So 2x is between 0 to 720. So the meaning of 2x means that there will be 2 rounds, 2 cycles, 2 rounds, okay? Right, so the first step sorry, the second step here will be alpha, cosine inverse 0.4. Okay, alpha is in the cube angle, so you have the cosine inverse a positive value. All right, so even though there's a negative in front of 0.4, you ignore the negative. You must cosine inverse 0.4 to get a cube angle. The next thing is to draw your ASTC. So for cosine to be negative, you come from second and third. Right, so from second quadrant will be 180 minus alpha, so 113.58. From the third quadrant will be 180 plus alpha, 246.42. And because we're talking about 2 cycle, whatever answer you get for 113.58, you must add one more round. 360. One round is 360. Okay. If you draw your unit circle, right, you start from here, 0 degree, then to 90, to 180, to 270, to 360. So you go one complete round, it's 360. So you add 360 to 113.58, and you also add 360 to 246.42. Then finally, all these 4 answers you divide by 2 to get your x. Because finally, you're actually solving the value for x. Okay, so we have completed the video on this solving trigo equations. You would observe that some of the steps involved are quite quite systematic. In other words, if you need to understand the concepts and then remember the steps well. And if you're able to remember the steps well, and then if you can just do it in a systematic way, most of the time you can actually solve any trigo equations. So to summarize, what are the steps? First of all, find new range. Okay, if you're not given cosine x, if you're given cosine 2x, 3x, 4x, or whatever, or cosine bracket 2x minus 1, that kind of thing, you have to find a new range. And then secondly, find alpha. All right, and alpha is in the cube angle, so we must trigo inverse a positive value. And then the next step is to determine the quadrants, your ASTC. But when you draw ASTC, also be careful because you will need to consider angle in a anti-clockwise direction, also angle in a clockwise direction. Because the range given to you, if it's always between 0 to 360, that is in the anti-clockwise, then you don't have to worry about clockwise direction. But in one example, remember, it's between negative pi to 2 pi, then you have to worry about in both directions. Right, and then finally, the answers you get will be, the final one is for x. Okay, so in between could be just 2x minus 4 or 2x. And then finally, whatever answer you have, just divide by. If it's just finding 2x, then divide by 2. If you're finding 2x minus 4, then whatever answer was plus 4, then divide by 2. All right, okay, thanks.